Good morning, everyone. My name is Thiagu Palaniappan with TriStar. Welcome to the Thursday webinar series. Today we'll be looking at the ANSYS AIM product. So we really wanted to go over some of the options available within ANSYS AIM to enable democratization of simulation in your company to the design engineers or the users that don't have experience or don't have specialized in the FEA tools. So I think AIM is really set up for that, and you can even customize it. Just wanted to go over some examples on that. Now this webinar will be recorded, and all of you are muted right now. Towards the end, we'll do a Q&A session. You can start typing in your questions right now if you have any questions as I do the presentation. So the next 30 minutes or so, my plan is to do a few slides, but then spend some time on showing you the product AIM with a few customization options that allows you to create or set up your own best practices and deploy analysis methodologies to the entire company. Thereby even new users can just go through some process-driven workflows or tasks to do the simulation on your products. And before we look at the agenda real quick, now one thing I forgot to mention is all of you who are attending this webinar, you would there's going to be we'll send out an email later this week or by the end of this week or early next week, since all of you have a chance, or at least one of you have a chance to win the tailor-made golf driver. So we are running a promotion on ANSYS that's valid through the end of September. So please visit our website or please reach out to your reps at TriStar to know more about this particular 50% off that we have on the AIM product, on the ANSYS AIM product. That said, from an agenda standpoint, we've been doing quite a few ANSYS webinars, so today thought of focusing more on the custom process templates, how that's done, and how you're able to enable it within ANSYS. So ANSYS does come with a default set of process templates out of the box, but in your company, obviously the simulation expert, if there is one, he could set it up for you, or you could set it up on your own. And there's even in the App Store at ANSYS, you can download some of these by yourself and try it out if you already own ANSYS AIM. So feel free to start typing in your questions in the chat session or the question area, and then I'll try my best to answer it towards the end. So as you know, right, simulation-driven product development is quite popular these days. When we work with engineering managers, or in my consulting experience, I've seen more and more companies trying to couple design with simulation rather than trying to create a prototype for everything and then trying to do an actual test. So over the, it's just been like 40 years or so when simulation or FEA has been there, but we could see that more and more companies or products, they have a lot more of multi-physics, simulation requirement rather than a single physics of either structural or thermal. Just to give you an example, if you take the car, the B pillar is tested for structural dynamics and crashworthiness, right? That would be one of the requirements. And then fluid flow simulation would be used to design the shape of the body to meet external aerodynamics and fuel efficiency requirements, what have you, right? So there could be several body shapes or iterations that are analyzed before even doing your typical wind tunnel testing, for example, right? Or it could be electromagnetic simulation, which might play a crucial role for developing and verifying, let's say, the next generation active safety systems, autonomous driving features, maybe vehicle-to-vehicle infrastructure communications or vehicle-to-vehicle communications, right? So what I'm getting at is, more and more we are seeing that, there could even be, for example, some embedded software, right, for the control system and displays, right, that needs to meet some electronic systems requirements or standards like EMI standards, and it needs to be properly cooled, right? So we are looking at whether it's a simple part or a complex design, there's going to be more and more requirements for all these different subsystems, if you will, to work in tandem rather than individually, right? So that's why it may not be just enough to do a structural analysis or just a thermal analysis or just a fluid flow analysis or an electromagnetic analysis. You will have to make sure that all these different physics talk to each other, pass information back and forth, so you can do like a combined simulation, right? So that's where I think AIM has been positioned for that. Over my consulting days and during my industry days, I've seen, the trend is that more and more users are starting to use simulation, right? Compared to a decade ago, or like in 2005, 2015, you see some numbers there that we got from ANSYS. As the expectation is, right, moving forward, we are going to see a lot more engineers and designers, right, other than the analysts, right, that would start or end up using simulation upfront in the design process, right? So in order to enable that, ANSYS has come out with this new tool, which some of you who have not seen it, we did an introductory webinar on ANSYS AIM. So I just pulled a slide from that real quick, just to give you an idea of what's AIM. So if you think about ANSYS AIM, it's an integrated solution for 3D engineering simulation, right, that has the breadth of ANSYS physics that we all know about, right, in a very easy to use environment. That's the key, right? So it's really built from the ground up on the ANSYS technology, on the Workbench platform that we are all familiar with, right, or we know about. They are like the golden standard in the analysis world, as you know. But the problem used to be that you have to be an expert ANSYS user to use the tool, right? So AIM's target audience is you, the designer or the engineer, the casual user, right, of the FEA tool, wherein you don't want to use something that's so easy, giving you inaccurate results. You want to have the accurate results. At the same time, it should be more of a process-driven workflow type tool, wherein you shouldn't be spending time to learn the software. There's not a lot of learning curve here with those predefined templates. At the same time, it allows you to bring in geometry from your native CAD tool or import geometry from most of the CAD systems out there, editing geometry, creating the meshing, running the physics, whether it's just single physics or multi-physics, right, and then results reporting. And finally, also the what-if scenarios, right? How would I improve my design once I look at my stress plots, or I'm looking for avoiding certain temperatures on my printed circuit board, for example? I could set up some limits. I could use my dimensions, parameterize them, use them as design points, and see how sensitive they are to my results. And at the end of the day, the goal is to make sure that you optimize your design, right? At the same time, you're going to get some accurate results from it to help you through that decision process, right? That's the key with ANSYS AIM. The power of ANSYS at the same time, easy to use with templates. So when I say easy to use, here's an example. You could see the process templates on structural, fluid flow, thermal, right, electric conduction. There could be fluid structure interaction where you want to do like a fluid flow analysis and extract the forces from the fluid flow to do a structural simulation to check the stresses and the deformation on that product, right? So all these are predefined. Most of these are predefined, but you can also create your own custom applications with a little bit of scripting. And they allow you to even create your own custom applications, which large companies, they may have a few analysts that are very experienced in the FEA tool, and they have developed some best practices over the years, right? And they would like to deploy that to the design engineering group that are not as experienced in the analysis tools, but they more work on the CAD side of things. So for them, rather than going through a learning curve with them and teaching them, which always it comes with experience so far, but it's trying to capture that knowledge into a custom template or an application within these process templates, right? I'll show you that during the demo. Now, out of the box, there are a few templates, like just a structural template that allows single physics, or it could even be a multi-physics template like fluid structure interaction or fluid solid heat transfer, right? Now this is predefined out of the box. When you install ANSYS, you get it, right? So it really gives you, it walks you through a series of tasks, right? The yellow bolt, right, lightning bolt right there tells you that it requires some tension, the physics is not yet solved, and then you can get the results, or you can edit the geometry, bring in the geometry, you can apply mesh control. So all those options are available, but it's almost like a guided workflow or a process that walks through the process with, even for a new user, very helpful. And this can be customized too. So you start with the geometry, right? If I were to look at one of those templates here, I would bring in the geometry. Like I said, I could have a CAD interface to Creo Parametric if you're using Creo, or if it could be any other CAD tool. They do have the CAD interface where you can make sure that it picks up the model in session that you have open in your CAD tool, or you could just bring in that file directly, read that file into ANSYS AIM, including the dimensions. Some of the dimensions can be parameterized, so to do some design exploration once you run the analysis. So once you do the geometry, the next step is obviously the mesh, right? All the different types of mesh are supported depending on are you doing like a fluid flow analysis or a structural analysis, right? And then you would define the physics, which would start off with material properties, right? There's a library of material properties that you can customize. For the most part, it should be available out of the box in AIM, one of your material properties, and then start applying loads and constraints, and then the post-processing, right? You just run or solve the physics and view the results, as you can see here. So it's more like it's the key thing is a simple workflow, right? But at the same time, behind the scenes, it's using Workbench platform and it's using ANSYS accuracy. You can really look at the accuracy, right, of the solution, and you can look at the actual accuracy as to how it achieved accuracy. Do you need to refine the mesh, things like that? You still have, for advanced users, you could always go back and change those, but out of the box, I think it's a pretty straightforward workflow. Now, here's another example where, all the way from geometry editing to results, you're using one single tool. So what you're seeing in this screenshot, the bike has been opened in ANSYS AIM. However, I can go to the geometry and do some editing, do some defeaturing, for example, right? The designer or the engineer has created the fully featured model, which may not, it may not be required in the analysis model. I can go defeature it, just edit geometry, and it takes you to Space Claim Design Modeler or Space Claims Engine behind the scenes, right? That's included with AIM. And that's what you see here, where, for example, you can extract fluid volume, right? You can extract fluid flow volume, which is quite a big task in many of the CAD systems out there. But ANSYS AIM's Space Claim can help you through that. And once you're done with the editing, you can even add some dimensions, make some changes, quick changes, without regard to parent-child relationship that you may be used to in your CAD system. Make some quick changes here. Capture some dimensions and expose those dimensions in AIM so that you can run some design exploration within ANSYS AIM. So like I said, it has pretty much a full capability with respect to geometry editing, right? So what you need, typically we call it preparing the model right for analysis, right? Wherein you may want to check for interferences or clearances, maybe, defeature some unwanted features or cosmetic features, quickly create that fluid volume that you see there. So all that is quickly done within AIM. And you can also have multi-physics templates or workflows where here you could see the first line is more of doing a fluid flow analysis where you may have to say the inlet, the outlet, the walls, right? Give it the pressure, velocity, etc. And then your output, you may be looking for mass flow rate, right? You may be looking for streamlines, path lines. At the same time, I would like to extract the force from my fluid flow analysis and apply it to my structural analysis. So how do you do that is you can couple these. So that's that little, you can see a little arrow there where you're able to see how it couples to the structural analysis, and both these physics are really kind of talking to each other essentially, right? And you can do this with, it's like a one-way, one-directional fluid to structure interaction, which is needed in quite a few designs, like in this example here. I may be interested in the fluid flow of this assembly, but I'm also interested in the stresses and the deflection on the components, right? Which, you can see that the structural results give you the stress plot, what you're seeing on the screenshot, and this is giving you the fluid flow, right? And then finally, you could add some design checkpoints. So here I've added a few design points, and you can see how I can run my analysis using those design checkpoints for specific outputs that I may have defined upfront in AIM. So that's the what-if scenarios. It's a big piece of your analysis process, right? You need to make sure you improve the design. What dimension should I work with? Do I just keep going back and forth by changing dimensions randomly or based on my experience, or could I use the software's capability to help me make that decision, right? Now, those are using other CAD systems. Please remember, you do have a direct integration, or I should say, an interface, I should say, with most of the CAD systems out there, so you're able to access, or at least it's not the full AIM interface, but you're able to launch AIM from within Creo or access a file that you opened in Creo in AIM, right? So that's the only thing is when you install, you can configure it, right, to Creo parametric, for example, point it to the folder where you installed Creo, so it can identify that, point it to the batch file of Creo's executable, so that with that done, within Creo, on the left-hand side, you could see where I do get an ANSYS 17.0 a tab, an additional tab for you to launch AIM, or you could launch AIM and then connect it to a live CAD session wherein you may have a few parts and then it picks up that part, or you could select from a list of active parts or assemblies and then bring it into AIM and start working on it, including the ability to export or expose dimensions or parameters. Like in this example, I've exposed the fillet radius and I've just parameterized it, right? So parameterize essentially allows you to create a design point, and now once I'm done running the analysis, I can create different design points and look at my displacement and stresses in a structural analysis, or in the case of a fluid flow analysis, I want to look at the impact on the mass flow rate, or if I'm doing a thermal analysis, the temperature distribution based on these inputs. Now, we talked about the existing templates, but automation and customization is a big piece in AIM, where those predefined templates could be used to run the analysis. However, one of your experts, analysis experts, what they can do is they could create some best practices, the way they apply loads, constraints. It's more like giving the user the choice to select the geometry where you want to apply loads and constraints, but maybe let's further automate it with a little bit of scripting. So the way that's done, here's an example where I'm showing you an example of a hip implant analysis. You could see that's a custom application, or what we call an extension within AIM, that I'll show you when I do the demonstration how that's invoked. But then when I use that, you see how there are some, apart from the guided process templates that you have, I'm building further upon it and adding my own process based on my best practice that I want to deploy throughout the company, right? So whenever we work on a model like a hip implant, for example, it has to meet certain standards within the company. I can add that, including the help file, right? You can include HTML help files for new users that will further assist them as to why they're asking you do a specific task. So the way that's done is using a combination of standard XML and Python languages, right? And the customer portal has information on how this customization is done, right? In fact, all these 4 apps that you see there, the internal flow app, the electrostatic field, the hip implant analysis, the wind tunnel extension that you see there, they're all available in ANSYS App Store if you want to try it out. So the way it works is as you set up your model in AIM, it's almost like in Creo-Parametric. Those who have used Creo-Parametric, you kind of know there's a trail file working behind the scenes. Similar to that in ANSYS AIM, there is this AIM journal file that gets added automatically, actually, in your sessions. It's in a particular folder that you can control. And it's essentially using some scripts to edit that, to capture some additional tasks using that, including, like I said, the HTML help file right here to automate, further automate the existing templates that comes out of the box. So here's an example of the electrostatic field extension. Here's an example for an internal flow custom template where I may just want the user may not be experienced in computational fluid dynamics or CFD. That's new to him. However, I could be the expert, or one of you guys who's the expert in that could set this up once, provide the inlet, the outlet values, right, for velocity, pressure, etc., and then, kind of guide the user to just select the specific geometry for this analysis input, right, from a setup standpoint, and then just view the result. In fact, you can even automatically generate reports, right? That's how far you're able to customize this. So here's an example of a virtual wind tunnel. So you can see the football in flight. That's an airfoil section, or wind loading on skyscrapers in the downtown area, for example, right? So all these actually are available. I'll show you in a demo in a little bit here. I'll show them briefly here, but you could try it out. It's in the ANSYS ACT application store. So with that said, let me switch to ANSYS. So what I have is ANSYS 17.1, the latest release. And let's say you do not have any custom template, right? If you do not have any custom template, the way that you would work on a structural model is obviously you go to your structural template, right? So these are kind of your different templates. I've not enabled any custom templates here, right? I go to my structural template. I get to import geometry, connect to an active CAD session, right? Set up the type of additional physics I may want to couple with the structural analysis. And I can essentially go and create a simulation process template, wherein I could say, okay, let's just select a part, right? Now, when I select that part, again, it could be a variety of CAD systems, right? It could read SolidWorks, Creo, right? Neutral files like STEP, IGES, right? Including, this is a space clean file that I have that I'm going to open. But what it's doing is, as it's opening that file, it's also applying, as you can see, a quick workflow right here at the bottom, right? You're a new user. Let's assume you don't know anything about AIM, and it's saying that the geometry is imported, right? But the mesh itself, right? That's having some issue, or maybe it needs your attention. So I go to the mesh here, and I can control the mesh resolution, apply some global setting, sizing options, right? And I can generate the mesh, and all these can be customized into that custom template I was talking about, right? So there is my mesh, and I go to my physics. That's the next step, right? And when I go to the physics step, I may want to go set up a certain material, right? So right now it's structural steel, but I could always go and use a different material if I have to. I could essentially type in, for example, polyethylene or something like that, right? Or I could go to my library here, and you can see that almost the entire list of libraries, a huge list of material library they have out of the box, right? So right now, let me just use the standard steel here. And I can change the properties, right? I can go to the structural steel, and you can see how I could make it temperature dependent, right? I can have a little table icon here for that, right? Change the Young's modulus, Poisson's ratio, depending on the alloy of steel, for example, right? So once I set up the material, the next step is, obviously I need to make sure that I add. So it walks me through. I'm a new user. The blue icons is telling that you don't have any structural conditions yet, right? I just follow that, right? So maybe I want to add some supports, right? So where do I add supports? So for that, for example, I could essentially even go just like you would do in your CAD tool. I'm just selecting geometry, right? I'm selecting geometries, and I'm going to say let's just add that as a structural condition, and that's where I'm going to support it, right? So it's essentially constraining it there, right? So so you see the ease of use, right mouse click, selecting the references, or just following your task right here. Now the physics task is still not complete. I may have to apply a load, right? So this is where I'm going to just say, so let's say I want to select some of these geometries real quick here, and I'm able to go add, again, a structural condition like a force or a moment or a pressure load. So in this case, let's say there's a bracket used to lift aircraft engines, right? So maybe they're going to, the crane, this is where it's going to be bolted onto the engine or, at the top, and then they're going to be lifting it with a crane. So obviously we want to, look for the worst case condition, right? So this is where I can apply the load as direction components, for example. And let's say I want to apply, in certain direction, whatever direction, I can go to X, Y, Z direction here and say, okay, that's going to be about so much. I could even change the unit system on the fly here, right? I could say I want to have that in pound force, for example, right? So what I'm doing is I'm just, setting up the model here, and I can solve the physics, or directly go to the results and update the result. So what it's doing as we speak right now is solving the physics, and it's also going to plot me some of the reports, right, or the results like deflection, right, and stresses that you may be interested in the structural analysis. Similar to this, for a fluid flow, the first thing would be extraction of the fluid volume, right? You need to extract that. Now, once the results once it has run the analysis, I even have the ability to show them right here, depending on what and what direction I applied the load. So I may be now interested in changing maybe that fillet, or maybe the whole location, or the thickness of that geometry. So I could always go back to the geometry, right? Now this could be from any CAD tool, and I could edit geometry. So editing the geometry is done right within AIM, right? So I'm essentially just selecting. I can just editing, and then when I close out of it, I'm in AIM in the analysis side. When I go to geometry, I just use the space claim tools to edit it, right? As simple as that. So right now, if I have to just select a bunch of surfaces here, for example, and I may want to move them, right? I could just use direct editing tools, right? For example, as you can see here, I could change that. I could even hit the little P there, essentially parameterizing that, right? And I'm done with the edit. I can get back to my simulate, and you see how it's asking me to update everything, right? So they're all in yellow, and it requires update. Similar to that, if I go to my results, on my results side, I could say maybe the equivalent stress, right? That's something that I may want to parameterize. That's something I want to keep track of when I change the whole location, for example, right? So similar to that, I could go to my deflection, right? I could say even my displacement. That's something I want to keep track of, right? The maximum displacement. So that's, again, something that I would parameterize. So this is almost like creating like design points and design outputs or analysis outputs. You're mapping them. So when I click here, when I go to my design points dashboard, it kind of gives me, it allows me to see, right, as you can see, what is the dimension I selected or exposed on the CAD side or in the editing geometry environment. And I could start adding, right? So for example, I want to have slightly different values here. 5. So I'm essentially, creating some design checkpoints, and if I were to update all, it's essentially going to run the analysis, and it's going to give me an idea of, what would be the equivalent stress, what would be the deflection when I make those changes to the design. So this is like just showing you the out-of-the-box template. What if I would like to customize this, right? Now, whenever you do any analysis like this, right, what the software does is it automatically creates, let me just show you some options here, where this journal file directory, right, where it is, right? So if I go to that journal file directory, so if I go to this one, so I do have the latest one, and this is essentially keeping track of all that I did, right? So journal file, as you can see, right? This is kind of what we just did, as you can see, right? You know, those different checkpoints I added, right? You can see how it's, so this is where I'm able to customize this and add. So let me go to my extensions here. I have about 3 extensions, one for a structural analysis, a fluid flow, a wind tunnel design. So I have 3 folders with the appropriate XMLs in there that I've loaded in, where we have ANSYS, and there's like a folder called ACT extensions. That's where I have it. Since I have those, what I can do is I can enable them within AIM. So right now, let me just close up this dashboard here. I don't have any add-on extensions, but I could go to my extensions and say, let's add the hip implant analysis, the internal flow, the wind tunnel design, right? So what I've done here is I've added these 3 custom applications, which may be created by my methods leader, my CAE leader, or he's the one who is trying to deploy this to the entire design group, right? So he created some of these, right? And now I could go to, for example, I could go to that hip implant analysis right there, and you see how I don't have to use these workflows anymore. It's just saying load the geometry file, right now. So I could go to my geometry file, and maybe I could load, let's say I'm going to open up a Creo file here, right? That's a .prt file. I'm going to load a Creo part file, and I say next. So I'm further automating the already automated process templates that we have out of the box with AIM. All right, so that's the goal being to make sure that analysis is available for every engineer or design engineer, right? That may not even be experienced in the FEA tool, and hence to democratize it, right? So the scripting, while it's loading it, when I was going through the slides, so that's it's using a combination of just go up here, right? If you know Python language or standard XML language, you're able to do some edits to those files, right? So you could just run a regular structural template first, and then tweak these so as to create these. So that's kind of how we got these extensions right in here, right? These 4 extensions that I have right there that you can also try out in the App Store. So now it's asking me for Young's modulus, Poisson's ratio. I could change it, right? I could change it right here. I could even say, hey, change the material, right? It's entirely up to me as to what tasks I expose to the user, right? He doesn't have to understand, for example, the meshing, where I am, the granularity in the meshing, or where I'm refining the mesh, etc. Those things could be something that an experienced FEA user knows that, but a new user, it's more like he's just applying the inputs, right, required to run the FEA analysis. So again, now it's asking me for the load location. So let's say I want to apply the load on this face, and I can change it here, but it's using whatever that was used during the original creation of that template, right? And as for supports, so maybe I may want to constrain it at that location, and the driver hole location. So maybe this is maybe when I plot the reports, I may want to know the stresses on the holes, for example. So that could be one reason why it's requesting me to select the surface of the hole, right? And just to speed things up here, I'm going to do a quick one here so you can run it fast. I mean, you have a variety of quick, medium, high So it's more like the time versus accuracy thing, right? So in the demonstration from a time standpoint, I'm just going to set it up to quick from an accuracy standpoint, and it's working on it. So essentially it is going through the same process like I showed you manually, where I had to update the results, but here instead it's going to give me a list of results that was already defined by the person who created this template, right? And this could be applied on pretty much any model, right? Or multiple variations or different variations of this design, right? It could be something that this company does often. So let's just apply it once, and then this is something that just like in the CAD world, I'm sure you guys use templates for your designing your parts, assemblies, drawings. Imagine the same thing with a lot more customization options in the CAE or the computer-aided engineering world or for simulation tools. And if time permits, I'll also show you the other apps, the internal flow and the wind tunnel. I'll just show you a quick example on that, and then we'll start with a quick Q&A. So as you can see, it ran through that. It's giving me the reports here, full stress. I could say give me the driver hole stress, the plotting level stress, etc. Right? We created like a plane there and showed the stress only at that level. I could hit finish here, right? And it's essentially going to give me, for example, all the reports. So if I look at my results, right? If I go to my results here, and here, the displacement magnitude, the equivalent stress, for example, and maybe that's something I may want to animate and see, right? I'm animating and seeing it. So similar to this, right? I could go open up another extension. So let me go and turn on manage my extensions here. Internal flow, for example, I know. And when I go to that internal flow template here, looks like I've even captured symmetry conditions. So maybe I'm going to work on one half of the model or the full model. First of all, let me just go open up the part here. This is the control valve assembly that I have, and I know it's cut in half, so I'm going to select the half symmetry, and I could say I'm interested in just the thermal flow or the stress, the temperature, etc. You see how I get to, so that my template is further customized is my point. And right now it's going through that geometry import. So I don't have to, I can just expose whatever the design engineer or the non-experienced FEA user, right, that needs to know to set up this, right? That's the key here. So now it's asking for the fluid symmetry. What's the plane, right? It needs to understand the plane for structural, so it doesn't deflect or dig into itself, for example, right? So we have cut the model in half in the interest of time. So that's where I'm able to say, okay, this surface is going to be my fluid symmetry plane, right? That's a fluid volume. And then for the structural analysis, this is going to be my symmetry plane. I'm just going to capture those surfaces real quick here. And I go next, right? So like I said, I could just be, this is the first time I could be using AIM, but then the template has been set up in such a way that now I'm going to go, okay, it's going to be water, air, what type of fluid, I can change that. The inlet velocity, I'll just give it some value for now for the demo here. Change the inlet temperature. Let me just leave those default, but where is going to be the inlet? So I'm going to say this is the inlet. And then I'm going to just say this is going to be the outlet. And I can change the gauge pressure, etc. Right? So whatever has been exposed for me in that template, that's really what I'm going through here. And then, once you can just, I'm not going to run this reports here, but, you see how you can look at the results for the mesh, for the flow, as well as for the report, for the stress results. Similar to this, you could also go and create, look at the extension. Let me just show this one last thing. Maybe like a wind tunnel design extension. And here again, I'm going to select the file first. So for example, let's see if I could open up. So here, let's see here, I could open up, for example, a part like that. You can specify the inlet velocity. Again, for the accuracy settings here, we'll just make it quick. So it's applying again, as you can see, the template. It's almost like another layer of automation on top of the already automated process templates that you have out of the box in AIM, which I think is very important. In my experience, I've seen usually when we talk about any type of analysis tool, right? There's the first thing that we hear from is, yeah, we outsource it to a company, or it's a specialized field. We don't have enough engineers experienced in it, or some of them have experience, but they've used it a long time back. So this is kind of addressing all that issues, right? So because it's based on the ANSYS workbench platform, that's the key. So here, let me just go open up some transparency. Here I have as you can see, a rough model of a car, and maybe I need to, I'm just going to simulate the fluid flow around it. And here, all I'm going to do is just update the results. And what it's going through is it's, initially it gave me the velocity, if you remember, right? I could set up the velocity. That's one thing I could have changed. But other than that, I'm just going to simply run the results here. It's working on it just got done with the mesh. It puts a green check on the mesh. Right now it's solving the physics. And the results, right? If you're a new user in CFD, what you might be, you don't have to go set up, okay, let's have a calculated value for mass flow rate. Let's have the path line. Let's create a plane and look at the pressure drop in that cutting plane, or so all those could be predefined. So it's really not only automating the setup, but also the post-processing or the report generation to a certain extent. So it's right now it's got done with the physics. You can see at the bottom, that yellow bolt is gone, the lightning bolt, and then it's in the process of doing the results. There it goes. And now if I go to my results, I have about 12 results here. So there was my streamline, there was a velocity, there was a pressure slice in the horizontal direction, there was a velocity here, right? So if I go to streamline, streamline 1, and if I were to animate that, right, you could see the change there, or if I could go back to the results here and look at the pressure and animate that. So as the car is moving, the fluid, you could see. So you're able to, this is something that, I know that with experience, who are experienced in CFD, they kind of know these to plot. They may want to calculate the drag force, lift force, right? If I go to that, so that's something that I don't have to set these up. In most FEA tools, as you know, pretty much in all FEA tools, you'll have to go and set these up as to what outputs you want, and I can even parameterize that. You see, it's already I parameterized also, so I could change some dimensions and see the effect of the drag force, for example, right? So let's go to my results here. Similarly, lift force, the iso surfaces, the velocity. Okay, so those are, again, like I said, if you visit the application store, you can download these. If you already have AIM, you can even try out these, and there's even some tryout step-by-step instructions on how to set these up, and just give it a shot, and then so that you could start applying it for your analysis, right? So with that said, let me see if you have any questions. could please type in your questions in the chat session or in the question area. All right, so it looks like there are no questions. I'm just looking at the chat session here at this time. Just to remind you about the offer, the time-limited offer on ANSYS AIM, please reach out to your account reps at TriStar, or please visit the website or call us if you're interested to know more information about this particular offer that's running through the end of September. With that, thank you for your time. We look forward to seeing you all in another webinar. Until then, have a great rest of the week. Thank you.